This lesson is on solving equations involving absolute value, and also we will be evaluating absolute value expressions. Absolute value is the distance from a particular point to 0. Distance is always positive or 0, but it is never negative. An example of that is when you're driving. So let's say you are sitting at mile marker 161, which is where the Walmart exit is, where Panera Bread, where Buffalo Wild Wings is. That's exit 161. You leave and get on the interstate and you drive to Rolla, and you go to the first Rolla exit, which is exit 184. You take care of your business. Maybe you go to eat at Applebee's, or you go shopping at JCPenney's, or you go to Walmart there for whatever reason because you didn't like the Walmart in St. Robert. And you get done, and you head back, and you drive back to exit 161. The distance that you travel, whether you are going to Rolla or coming back, is the same. If you go start minus finish, finish minus start. So the finish going to Rolla, you ended up at exit 184, but you started at exit 126. 161. And then you flip that around when you headed back. But that value is going to be the same. This is the absolute value of 23, which is equal to the absolute value of negative 23. So both the distance traveled, whether going east or going west, is the same. It's 23 miles. So there's an understanding of absolute value in the real world. Solving absolute value, evaluating absolute value expressions. Here we're given a variable. A is equal to 5, so it says replace A with 5. So we're going to put a 5 right there where the A is, keep everything else the same. And then you just follow all order of operations. Absolute value bars are the grouping symbols. So anything inside of the absolute value you do first. So 5 minus 7 is negative 2. And the absolute value is always positive, so the absolute value of negative 2 is positive 2. And so our final answer is 17, evaluating with absolute value. Solving absolute value equations, you have to always consider two cases. First of all, make sure that you know that the first case is going to be positive or 0, or we call in math world, we say non-negative. Now, if it's the case of being 0, there's only ever going to be one solution. But with two solutions, you'll have one, or with something that's not 0, you'll have a situation where it's positive and a situation where inside the absolute value, that keyword inside the absolute value, it's positive, and inside the absolute value, it's negative. So we take what's inside the absolute value, the 2x minus 1 in this case, and you take it outside of the absolute value bars, and you set it equal to a positive number. And then you take that same thing, what is inside the absolute value bars, and you set it equal to the negative value. So they're set equal to opposite values. And then you just go through your process for solving like you do any other equation. So we'll add 1 to both sides, and we have 2x is equal to 8. Over here, when we do case, well, let's just finish out this one here. And then we'll divide by 2, what it says right there, and we get x is equal to 4. So that's case 1. We're going to do the same operations with case 2. It just is set equal to a different number, to the negative number. So we will add 1 to both sides, and we get 2x is equal to negative 6. And then we divide by 2. We get x is equal to negative 3. If you would plug in those numbers into the problem to check, so 2 times 4 minus 1 is equal to 7. 2 times 4 is 8, and 8 minus 1 is equal to 7. So this would be the absolute value of 7 is equal to 7. If we plug in negative 3, absolute value of 2 times negative 3 minus 1, is that equal to 7 also. You got to check with the original problem. Don't check with the case 2 value, okay, because we put back the absolute value bars around that again. So we go to the original. So check with the original equation. So we evaluate that, and we get the absolute value of -6 minus 1. That equals the absolute value of -7, and that is also 7. So we know that those work. So our answers are -3 and 4, and I noticed that I did not put the right scale to take me to 4, so I'm going to change and add these tick marks in here. So now we can fit our answer on there. Make this a little bit bigger. All right. So our solutions are -3 and +4, and that's how you graph just equations on the number line. They will always be 2 points, and unless it's the case of it being equal to 0, then it would just be 1 point. But most every time, the ones that we're going to do are always 2 points. When we go to inequalities, then we will have shading with those 2 points, but that's for another day. All right, here is a case where the absolute value is equal to a negative number. Absolute values can never be negative, the bars itself. Inside it's okay, but outside it can't. So the distance can never be negative, so this solution is an empty set. We would say no solution, okay? Or you would say an empty set like that. Now what happens if the absolute value has stuff around it? Like this has the absolute value of 2x minus 1 inside the absolute value bars, but then we have a -3 outside the absolute value equal to 6. Before you can set up 2 cases to solve that, absolute value must be isolated. It has to look like this other problem here, where there's nothing to the left or to the right, nothing being multiplied, nothing being added or subtracted, no division, nothing, just the absolute value all by itself. So in this case, we have this 3 being subtracted from the absolute value. So we're going to add 3 first. That's step 1. Isolate the absolute value. So we still have the absolute value of the quantity 2x minus 1. The 3's cancel, and we have 9. Now we can set up our 2 cases to solve. So we have 2x minus 1 is equal to 9, and then 2x minus 1 is equal to -9. Then we solve just like we have done, so we'll add 1. 2x is equal to 10, divide by 2, and we have x is equal to 5. In the second case, we add 1 also. 2x is equal to -8, divide by 2, and we get x is equal to -4. And you can plug those in back into the original, and you will see that they will, when we subtract 3 from the absolute value answers, you will get 6. Here's another example. This time it has a -2 being multiplied to the absolute value. And yes, it is equal to -2, but you can't decide if this is a no solution until the absolute value is all by itself. So when we divide by -2, now here is an error that is often made. Never, never distribute into absolute value bars. These are like prison walls. You're not going to jump inside because you want to, okay? Never jump inside there. There's like concertina wire all around here. You can't go in there. You don't want to. Don't jump in. Never. They are like grouping bars, but they are not, or grouping symbols, but they're not like parentheses, so you can't jump inside there. You have to clear it out through division. So we have the absolute value of the quantity x plus 3 is equal to 6. Now we can solve this. So 2 cases, x plus 3 is equal to 6. Remember, there's no absolute value bars on our cases. And then x plus 3 is equal to -6. And all we have to do is subtract 3, and we get x equals 3. And then we subtract 3 here, and we get x is equal to negative 9. If you plug in 3 here, 3 plus 3 is 6, and then the absolute value of 6 is 6, and 6 times negative 2 is negative 12. Same thing over here. When I plug in negative 9, this time I'm going to get the absolute value of negative 6, and the absolute value of negative 6 is positive 6, and positive 6 times negative 2 is negative 12. So those work. Okay, one more where it has a little bit of both on there. So the first thing we're going to do, just like order of operations, we're going to get rid, or in reverse, our solving techniques. We're going to subtract the 1 first. So we have 3 times the absolute value of the quantity x minus 4 is equal to 9. Then we're going to divide by 3. You always have to do that. Always. Can never distribute. Never, ever, ever distribute. So we have x minus 4. The absolute value of that is equal to 3. Now we have our cases. X minus 4 is equal to 3. X minus 4 is equal to negative 3. Add 4. X is equal to 7. Add 4. X is equal to 1. And that is solving absolute value equations when the absolute value bar are not isolated. Here are 3 problems to do on your own, and turn in your answers to the substitute, and we will look at them together tomorrow.